Hey everyone, welcome back. So today we have another problem of the day, that is find the winner of circular game. The problem states that we have given an array and it will be in a circular fashion. And what we have to do is we have to select a candidate from the first point and we have to count the k amount. Okay, they will be giving us the another parameter, that is k. So we have to count. For example, in this the k is 2, so we will count 1, 2, and we will remove these two from our circular list, and the remaining will be this. Now we will be starting from the next element, that is 3, because we have just removed 2, and from 3 we will be counting k elements, that is 1 and 2, then 3 and 4, and we will remove the fourth element. And similarly we will be starting from fifth. We will see what are the elements, and in the same fashion we have to do till we have only one element left, and that will be our answer. And this problem is pretty much straightforward, and there are two solutions for this problem. In the first solution, we will be using DQ. It won't be an optimal approach, it will be depending on the value of k. But the second approach, which is recursion, it is an optimal, and the time complexity will be n square. But let us just assume we are using DQ because it is just a best practice to learn about DQ, how you can use them. So let us take an example that we have 7 elements. These are in circular fashion. I'm just drawing it as an array, and this is in our queue, and we have value of k is equals to 3. So what we will be doing is, the first thing is that we will insert our values in. So first we will be inserting our values in a DQ in the reverse fashion, that is 7, 6, 5, 4, 3, 2, 1, and now we will be operating this. In the first cycle, what we are going to do is we will be counting how many number of elements we have to remove. So we have 3, so we will remove this, and when the element is 3, that means we have to remove it completely from our DQ. And what we will be doing is, once we remove this element, we will push back it in a front, that is 1 and 2, and the remaining element will be same, 6, 5, 4, and we don't have any other element from in this section because we have removed 3. Now, similarly, we will go ahead and see what is the topmost element. So we have the topmost element as 4. That means we will insert it back here. That is 4, and then 5, because we have to delete this 6 this time because it is on the third position. That is 1, 2, 3, and the remaining element goes as it is 2, 1, 7, and we have two empty slots now. Okay, similarly now again we will be seeing 3 counts, that is 1, 2, 3. We will remove this, and the left array and the remaining array will be 1, 7, 5, 4. Again we will count 4, 5, 7. That means 7 will be gone, and again we will push the remaining element back. That will be 4. Okay, that will be 5, 4, 1. Again, we will count the number of elements, that is 1, 2, 3. 5 will be removed. Now we have just 2 elements, and those will be on. And how we will be inserting it? It will be 4, 1 again. Again, we will be counting 1, 2, 3, and the 1 will be removed. So the remaining answer will be 4. That is our main answer. Okay, let us see how we can code this in C++. First, we will be initializing a DQ. A DQ is basically a queue that has two ends. We can pop it from front or back, and we can also insert it in front or back. I will be naming this DQ. We will be inserting the arrays. It will be from reverse. I is greater than equal to 1, I minus minus dq dot push back I. Okay, and the operation that we have to continue will be till point while our dq size is greater than 1. Okay, now we will be applying again a loop, that is while, that will be for loop is less than k minus 1 I plus plus. And what we will be doing is we will taking the last element, that is dq dot back, and we will remove the last element dq dot pop back, and we will insert the last element at the front. Okay, this way we will be continuing our circular list, and once this loop breaks we have to remove the last element and we don't have to push it back. dq dot pop back. Okay, and then all you have to do is return dq dot front, because there will be just one element in that. Let us run this. Okay. So there is another solution for this, that is a recursion, and this will be an optimal approach. And in this, what we are going to do is we will be recursively calling the same array, but we will be removing the array from that index. So to do that, I will be using a vector, and then we will insert the elements in that. Okay, and then we will be having the index that will be uh, that will help us to point out the element that we have to remove in that array, and I will be returning a recursive calling function. I will pass some of the parameters to that. That will be length of the array, the k pointer, then the vector itself, and the index. We will take this solution solve function here, int n, int k, vector, int vec, and the index. So our base condition for this will be when our vector size is 1, size is equals to 1. That time, all we have to do is return the first element. Similarly, that we have done in Q. Now, what we have to do is we have to calculate the index that we are going to remove. We can do that in a circular fashion. That will be the pointer at which we are pointing, idx plus n plus k minus 1 percentage n. And we have to remove that dot erase plus idx, and all we have to do is return the same thing, that is n minus, the length of the array will be decreasing this time, then k, and then vec and idx. Let us run this. Okay, so this is an optimal approach. That means the solution has 100% uh, runtime. And thank you for watching.